Good day, everybody. We are going to look at extra credit question 4 now. So the question reads, the average weight of all residents in town XYZ is 168 pounds. A nutritionist believes the true mean to be somewhat different. She measured the weight of 36 individuals and found the mean to be 169.5 pounds with the standard deviation of 3.9. So there are two parts to the question. A is state the null and alternative hypotheses, and part B is at the 95% confidence level, is there enough evidence to discard the null hypothesis? We can use the p-value method. And as always, I will pause for about 10 to 20 seconds. Please take your time and see if you can try this problem on your own. Okay, hopefully you're able to pause the video and approach it on your own. If not, here is how I approached the solution for this problem. So the first part, or part A, talks about stating the null and alternative hypotheses. And the null hypotheses should be the true mean weight of all residents in town XYZ is 168 pounds. The alternate hypotheses, or HA, which is not H naught, is the true mean weight of all residents in town XYZ is not 168 pounds. So for part B, the question asks, at the 95% confidence level, is there enough evidence to discard the null hypotheses? And we are supposed to use the p-value method. So let's start off with what we are given, as always. What we are given are values for sample size n, which is 36, the sample mean, which is x bar, of 169.5 pounds, sample standard deviation or value of S is 3.9 pounds, and then hypothesized population mean or mu naught, which is 168 pounds. And the confidence level is also given at 95%, which means the alpha value would be 1 minus 0.95, which should result in alpha value of alpha value of 0.05 when you subtract that from 1. So to determine if there is enough evidence to discard the null hypotheses, we need to calculate the p-value and compare the p-value to the significance level of alpha, which is 0.05, as we saw just a minute ago. All right, so to calculate the test statistic or z-score, here's the formula that we'll use. So z equals, in the numerator, we'll have x bar minus mu naught in parentheses and divided by the denominator of S, which is standard deviation, over, in the denominator, square root of n, which is sample size. So we're just going to plug and chug the values that were given. So that should result in 169.5 minus 168 divided by 3.9 over square root of 36. And when you simplify the numerator, it should come down to 1.5, and the denominator should get resolved to 0.65. And when you divide those two numbers, the z should result in 2.31. Then our next step is finding the p-value using the z-score. So just some theory. The p-value represents the probability of obtaining a test statistic at least as extreme as the one observed, given that the null hypothesis is true. So we can use a z-table or a calculator, and the p-value for a two-tailed test with z equals 2.31 should approximately give us a result of 0.0208. Then our final step is to compare the p-value to the significance level. Since the p-value, which is 0.0208, is less than the significance level of alpha, which is 0.05, we have enough evidence to reject the null hypotheses at 95% confidence level. And the final answer is, therefore, there is enough evidence to conclude that the true mean weight of all residents in town XYZ is not 168 pounds. And it turns out the nutritionist was correct. Anyways, I hope you enjoyed the problem and you learned something from this. Thank you so much for reviewing my extra credit question 4. Have a good day.